Now, to follow up from the previous video I made where I found the area of a circle, now I'm going to find the circumference of a circle. Now, doing the same thing we did before. Here's our x, here's our y. Alright, it's okay, it doesn't have to be perfect. Now, instead of finding the, we want to find our circumference instead of area, which is also known as the arc length. So same thing we did before. Of course, y is going to be our square root of r squared minus x squared, and of course that is our negative. So, what is the arc length? So, we know the arc length we're going to call it S, is the definite integral from a to b, square root of 1 plus the derivative squared dx. I might show the formula for this another time. So, we're gonna let f of x, and like we did before, we're also gonna just find the arc length of 1 and multiply it by 4, or for simplicity purposes, let that, of course, the square root of r squared minus x squared. And now the derivative of this, f prime of x, is equal to, we got a square root, we got 1 over 2 square root of r squared minus x squared, and then we got chain rule times derivative of this, of course r squared is a constant, and this is a minus 2x. 2's cancel, and we got minus x over, make sure we see that minus sign, r squared minus x squared. And of course f prime of x squared is going to be, well, the minus is going to go away, so we got x squared, and then the square root and the square are going to cancel, so we just get r squared minus x squared. Okay, so now we have what we need. Okay, so S, we can apply this, and once again we got our 4 times the integral going from 0 to r, and we got the square root of 1 plus x squared over r squared minus x squared dx. And now what I'm going to do, we still got our 4 to 0 to r. Rewrite this 1 as r squared minus x squared, to get a common denominator. There's plus x squared. And now these x squareds inside will cancel. So we are left with, we're left with the square root of r squared. And that's just going to be an r. So we're going to pull out that for r. Okay, for r times our integral from 0 to r. So, and we have 1 over squared dx. And now I think we can evaluate this integral. If I remember correctly, we get 4r times the arc sine or inverse sine of x over r. And we evaluate from 0 to r. It's going to be 4r. And it gives arc sine of r over r. So we get arc sine of 1 minus arc sine of 0. And pretending this is a unit circle, again, we're finding the sine of what. So this is basically the same as inverse sine. So the sine of what angle is going to give us 1? Well, there are infinitely many answers, but we're going to restrict our domain from 0 to 2 pi. So sine of 1 is here, or sine of an angle is 1 at the point 0, 1. And that angle is pi over 2. So we get 4r times pi over 2. And of course, and since we know sine of 0 is 0, likewise, this doesn't change. So we just get a minus 0. And since 4 over 2 is 2, and rearranging a bit, we get 2 pi r. And we're done there as well.